All right, welcome to chemistry. In this video lesson, we're going to look at week 13A. Of course, we're not going to do those problems in particular, but we're going to give you everything that you need to be successful in doing that. So one of the first things you need to do before starting this lesson is you need to click on the calculator so that you have a Desmos calculator available. And then next thing you need to do is click on the periodic table because you're going to be using that toward the end. So just to get started, I'm going to use a different format than formative to show this lesson. You should be familiar with the tools in formative by now, but in this video, I'm going to use the notes that we used in class. Okay, so if you missed the notes or you didn't get them for some reason while you were in class, now is a good time to go ahead and take those. And then also just make sure that you pay attention to anything that you may have missed while in class. So a couple things to note. In this, we are going to be going from mole to mole using the balance equation, mole to mass using the balance equation, and mass to mass using your balance equation and the molar mass of compounds. So in the balanced equation, it's very important that you note that it gives the mole to mole ratio of different compounds. So for instance, we would say the mole ratio of hydrogen, H2 over here, to water or H2O is going to be a 2 mole to 2 mole ratio. All right. So we look at the balanced equation in terms of mole. 2 moles of hydrogen will produce 2 moles of water. And when I have 2 moles of hydrogen and 1 mole of oxygen, I will get 2 moles of water. I could also say 1 mole of oxygen is equal to 2 moles of water. So that is the ratio that we are developing, but they are in the unit of mole. All right. Every time I speak in terms of a balanced equation, I'm using the word mole. Now, when we get to molar mass, now this is going to give us the mole to mass ratio of the same compound. So if you noticed, we see hydrogen over here. It says 2.02 grams per mole. What that means is that we have 2.2, let me write it over here, 2.02 grams of H2 for every 1 mole of H2. So notice that they are the same compound, all right? And the same thing with O2. We have 32.00 grams of O2 is equal to 1 mole of O2. So it's important to note that while you have a mass to mole ratio, it is also the same compound, all right? Because you will not see a mass to mole ratio of one compound to another, all right? You will see the mass mole ratio within the same compound. Okay, so I'm going to erase that. And then your question may be, well, where are you getting these molar mass values? And that is a very good question. And I want to bring that up because toward the end of this assignment, you will have to be calculating molar mass. And so just to show you how we got this, I'll make sure that looks like a 2 and not an E. So there's H2. We'll do the molar mass calculation of H2. And so for H2, the only thing that we have in this formula is hydrogen. So we would put in hydrogen. All right, so I'll write in element symbol, hydrogen. I'm not going to need these because they don't have any other elements in hydrogen. All right. Now, how many hydrogen are in H2? Well, that's very easy. 2. Then the question is, what is the molar mass of hydrogen? And this is where you're going to use your periodic table. So you're going to go to your periodic table that you have open. You're going to find hydrogen. All right. And we see hydrogen. Let's see if we can expand this view. And we see that hydrogen is 1.0079. I'm going to round that to 1.01. All right. And a lot of periodic tables do that. So we'll say 1.01. And go back to the right program. So we'll put in 1.01 grams, and it's actually grams per mole. All right. And so what is 2 times 1.01? Well, if you're having a hard time with the math, don't feel bad, but do use a calculator. All right. So you can then go to a Desmos calculator and you can say 1.01 times 2, and you get 2.02. All right. And what you will notice is that 2.02 grams per mole is not going to be added to anything else because we don't have any other elements in H2 or in molecular hydrogen. And so our molar mass is 2.02 grams per mole. And that's exactly what we're getting. All right. There. All right. So that is how we get the molar mass. Let's do it for oxygen. So for oxygen, very similar to hydrogen, it is only made up of one element, and that is oxygen. Very similar to hydrogen, it has two, and you may notice this, that both of them are one of those diatomics. All right, hydrogen is a diatomic, oxygen is a diatomic. And then you need to know the molar mass of oxygen. So we'll go to our periodic table, and on our periodic table, we find oxygen, and we see that it's 15.999. We're going to go ahead and round that to 16. So we're going to say 16 grams per mole. And then 2 times 16 is 32 grams per mole. Okay, and so we don't have any other elements, so we're not using these lines. So we're not going to use them. So we're not adding anything to 32. So it's just going to be 32 point. And if we wanted to put two decimal places, we could. They're zero, so it's not that big of a deal. If I said 32 or 32.00 grams per mole, there is a difference, but it's not that big of a deal in this lesson. All right, and then let's go to water. Now, water is going to be a little bit different than hydrogen and oxygen in that we have two elements involved. So we have hydrogen and we have oxygen. All right. And so you should be able to know that we are not going to need this line. And you should also know that there are two hydrogen and one oxygen. Now, one thing I want to make sure that we understand is that we're not looking at our balanced equation here. Okay. We are only looking at the compound H2, O2, H2O. We are not considering the coefficients in our molar mass calculation at all. So do not use coefficients in your molar mass calculation. That is a no-go. All right. So I'm only seeing H2O, no coefficient. All right. So that means there are only two hydrogen, one oxygen. And so we've already looked at the molar mass of hydrogen. We saw that it was 1.01 earlier. You know to go to your periodic table for that. So it's 1.01 grams per mole. And we know that 2 times 1.01 is 2.02 grams per mole. And that's because it matches hydrogen just perfect, just what we did earlier. Now we have oxygen. There is one oxygen. We said the molar mass of oxygen is 16. All right. And we'll say grams per mole. And so there's 16 grams per mole. So now we're going to add up 16 plus 2.02, and we get 18.02 grams per mole. So we see that this was matching that. And we also see that this is matching that. All right, and that's where we're getting those values, okay? And very easy to calculate. You have the template there to help you when you need to calculate molar mass later on, so please use that. But that's how we get those values. All right, getting to the questions or the example questions, we want to say, how many moles of oxygen are needed to produce 4.44 moles of water? Now, when we have a bracket, it is very important that you note that we are going to write the given in the top left corner, and the given is going to be some number with a unit that is given in the problem. So you must include compound and unit. All right. Now, when we go down here to the bottom, we're going to use the same unit and compound as up here. All right. And that's going to always be the case. Not any numerical values, but the unit and the compound. And then we're going to do our converting unit up here. So what are we converting to? Converting unit and compound. So this is the template. Given, include the unit, the compound and unit. The same compound and unit is going to go down in the bottom, and then our converting unit and compound. And so that's what we get to. So let's look and see what that looks like when we put this in a real problem. So we have 4.44 moles of water. So notice that this is given in the problem. So this is our given. So we're going to say 4.44 moles of H2O. Now, we said the same unit and compound would go down here. What's my unit and compound from up here? That's right, moles of H2O. Notice I did not put 4.44 because that's not what we need there. We need that unit. And what are we trying to convert to? We have to ask ourselves, what are we converting to? We have moles of oxygen. So we're trying to convert to moles of oxygen. Well, can we go from moles of water to moles of oxygen? Well, let's see. A balanced equation will give the mole to mole ratio of different compounds. So I can go from moles of water to moles of oxygen. And notice this, water and oxygen are different compounds. So we can use the balanced equation to do that. And so if we can go from moles to water to moles of oxygen, then we should do that. Now all we have to do is put in the ratio. All right, so what is my coefficient for water? Clearly it is 2. So we'll put 2. What is my coefficient for oxygen? Clearly it is 1. All right, if no number appears, that means 1. Now we just need to cancel some units. If we have the same unit in the top as we do the bottom, we cancel the unit. All right, and that's what we did. And then you're left with the unit moles of O2. All right, and that's exactly what you're trying to find. You're trying to find moles of oxygen. So what is it? Now let's just take care of the numbers. So we take 4.44, all right, and we're going to multiply that times 1, which happens to be 4.44, and then we're going to divide by everything on the bottom. So we only have 2 on the bottom, so we'll divide by 2. And so 4.44 divided by 2, if you say 4 divided by 2, that is 2. 4 divided by 2 is 2, and 4 divided by 2 is 2. So our answer is 2.22 moles. Let me make that 2 look a little better. 2.22 moles of oxygen. Okay, so a pretty easy activity there, right? Pretty easy conversion. And this example, or example 1, we just used a mole to mole conversion. And you'll know you need a mole to mole conversion if they ask you how many moles and they give you moles. You see that? All right, let's go to example 2. Now it asks how many grams. All right, and grams is a unit of mass. How many grams of oxygen are needed to produce 4.44 moles of water? So now we have to ask ourselves, what is the given? And the given is 4.44 moles of water. We use the same value we did in example 1. So 4.44 moles of H2O. And you should know what unit goes down here? That's right, moles of H2O. Now, can we go from moles of H2O to grams of oxygen? Let's see what we have. I don't know where that's coming from. So the balance equation allows us to go from moles to moles of different compounds. So we can go from moles of water to moles of oxygen, but it will not, the balance equation will not allow us to go from moles to grams. So we can't use the balance equation to go from moles to grams. What about the molar mass? The molar mass will give us the ratio of the same compound. So I can get the mass of water, right? Because I know the moles of water, but I cannot go from the moles of water to the mass of oxygen. Okay, this is the same compound. So if I'm dealing with water, I will only get the mass of water from the molar mass of water. So what do? Neither of these paths work directly. So we have to do a little bit more work than we did in example 1. And that is exactly why our bracket is larger. So since we cannot go from moles of water to grams of oxygen, we have to go to the next best path. And we can go from moles of water to moles of oxygen. All right. And so let's do that. I'll go to moles of oxygen. And we just did the same step in the previous problem. We go to our balanced equation. We see 2 moles of water is 1 mole of oxygen. And so we plug that in. 2 moles of water is 1 mole of oxygen. And then now we have to continue on because we are not at grams of oxygen. So what unit is going to go down here? That's right, moles of oxygen. So if you've noticed, whatever unit is up here appears down here. Whatever unit is up here appears down here. Now, can I go from moles of oxygen to grams of oxygen? The molar mass gives the mole to mass ratio of the same compound. So if I know the moles of oxygen, well, then I know the mass of oxygen. So I can use the molar mass, all right? So I can go to grams. So I'm going to go to grams of O2. Now all I have to do is plug in the ratio, and the ratio is 32 grams per 1 mole. All right, that's what that's saying. So it says I have 32 grams, and a lot of people like to get these twisted. Don't get it twisted. Look at it and see what is associated with the grams. It's 32. What is associated with mole? 1. All right, and so make sure you place them in the right place. Okay, now we are at grams of oxygen in our last bracket. So we say we have nowhere else to go. We found what we want to find. We found what we needed to find. So we are now going to cancel some units. And so we see we have moles of water, moles of water, moles of oxygen, moles of oxygen. And now we're left with grams of O2. And that's what we're looking for. And so let's take care of the numbers now. The numbers tell us that we have 4.44 times 1 times 32. So we would put in our calculator, 4.44 times 1 times 32. Now, I would never suggest you putting times 1 in your calculator, as it is a big waste of time. So we're going to put 4.44 times 32. And we're going to get 142.08. All right, so we get 142.08. And I'm leaving the units out of this because I've already canceled units and I've already put my unit at the end. All right, so this is why I'm just dealing with numbers at this point. Now, on the bottom, we still have to multiply these two values, and then we would divide it into the top. So 2 times 1 just happens to be 2. All right. And so now all we have to do is take 142.08 and divide that by 2. All right. And so one way to do this real quick, if you don't want to type that in again, if you just hit answer, notice that's your answer. And then you would say divided by 2. All right. And you get 71.04. All right. And so let's go plug that in. Kind of forgot what it said already. 71.04. All right. So 71.04 grams of O2. All right. So that's all there is to that. Pretty easy. Now let's step that up. Now, what did we do before we go to the next problem? We went from moles to grams. All right. This is going from moles to grams. All right. How do I know that? Because I was given moles and I found grams. All right. So moles to grams. And notice that my bracket was a little bit bigger than the mole to mole bracket. Let's go to example 3. And in example 3, I'm going to change this value. I want to change it to 16. So in this one, we are going from grams of oxygen to grams. All right, so now we're going grams to grams, and notice the bracket got larger. Okay, so what are we going to do with that? Well, first, we're going to find our given, and our given is in the problem, 16 grams of oxygen. So we're going to write in 16, and since we put 0.00 grams of O2. Now, what goes in the bottom? That's exactly right, grams of O2. So if we have grams of O2, what can we convert grams of O2 so that we could get to grams of water? Well, I can't go from grams of O2 to grams of water. I have to go the way of the mole. All right. So the only way that I can use this balance equation to show the ratio is to get to the unit mole. I'm in grams of oxygen. I need to get to moles of oxygen. So I'm going to use the molar mass because that takes me from mass to mole, grams to mole. And so it is 32 grams per mole. So we're going to put grams of oxygen to moles of oxygen. And then make sure you pay attention to this, all right? Because this says 32.00 grams per mole. Here is a conversion factor that you can get from oxygen. You can say 32.00 grams for every 1 mole, or you can say 1 mole for every 32.00 grams. These expressions are the same because they are equal. 1 mole is 32 grams and 1 mole is 32 grams. All right. So if you look at this one, those are equal values. If you look at this one, those are equal values. So there's no difference between them. When divided, they both equal 1. So if you look at 1 dozen and I divide that by 12, I would get 1. If I said 12 divided by 1 dozen, I would get 1. All right, because 12 is a dozen. All right, they're equal. These are also equal. All right, and that's the idea, and that's why they can be reversed. But when you're putting them in these conversions, they have to be the correct orientation, meaning 32 always, notice this, 32 is always with the unit gram, no matter what. So make sure if you have the unit gram in the bottom that you have the number 32 with it. All right, as long as we're talking about oxygen. So 32 grams is equal to 1 mole. Now we go to the next part, and we know we're going to need moles of oxygen. Now, moles of oxygen cannot be converted right into grams of water. Again, we have to use the balance equation to go from moles to moles. So we now can go from moles of oxygen to moles of water. All right, so we can say moles of H2O. And now we just plug in our coefficient. What is our coefficient of oxygen? 1. What is our coefficient of water? 2. So our coefficient of oxygen was 1. Our coefficient of water was 2. And then now we go to the next part of our bracket because we are not at grams of water. So now we're going to say moles of H2O. And can we go from moles of H2O to grams of H2O? Absolutely, because we can go from moles to mass or moles to grams we can get a ratio of the same compound. And we're going to look at water. So we can say 18.02 grams, and that is the mass of water, is equal to 1 mole of water. So 18.02 grams. And so let's go here. Let's put the unit in, grams of H2O. And now we know that 18.02 grams is equal to 1 mole. All right. And so now we are at grams of water. So we know we can stop. So now let's cancel units. Grams of oxygen, grams of oxygen, moles of oxygen, moles of oxygen, moles of water, moles of water. And so now we are left with just the unit grams of water. Now, what do we do with this? We're going to say 16 times 2 times 18.02. So 16, and we can say 0.00 times 2 times 18.02. And we're going to divide that by 32 times 1 times 1, which is 32. All right. And so let's plug that into our Desmos. All right. I think we say that in third hour, maybe a little more aggressively than anywhere else. So we had 16 times 2 times 18.02. So we're going to say 16 times 2 times 18.02, and we get 576.64. And then we're going to divide that by 32. All right. And so again, if you want to help yourself go a little bit faster, you hit answer, and then you say divided by 32. And we get 18.02 grams. So 18.02 grams. And just to make sure this is a little bit easier to read, I'm going to say 18.02 grams of H2O. And that is our answer there. All right. And so that should help you answer any types of questions that you have along the way. You are going to be doing some balancing. You're going to be doing some molar mass calculations, and you are also going to be doing some conversions. So this is chemistry. All right, guys, thank you for watching. Please like and subscribe. Tell your friends. I'd like to see a few more subscribers. I'm almost to 70. If we could get to 75, that would be really wonderful. Okay, thank you for watching.